Hello.
Good afternoon, everyone. Can we start the session, sir?
Yes, sure. We can start.
Yes, sir. Good afternoon, everyone. Today's topic is pre-engineered building system. Now I welcome our expert, Sri M.V. Jayaranjan, sir. He has 25 years of experience in different area of mechanical engineering. He is BTech in mechanical engineering from University of Calicut. He has working experience in academic institution and industrial firms. Now over to you, sir. Thank you so
Okay,
much, sir.
thank you. Okay, thank you, student. Sorry for the trouble because I don't know my mic was not working, and screen was saying okay. When I tested that, also saying okay, but unfortunately it was not working. So let us start our today's topic. It is Introduction to Pre-Engineered Building System. PEB, that is the short form. Now, in the industry, we will say PEB. Hello.
Yes, sir. Please wait for 2 minutes, sir. Please.
Yeah.
Yes, sir. Please take the session, sir.
Okay. So PEB is the short form of pre-engineered building, and in the industry normally we will use the short form PEB. That is pre-engineered building. Nowadays, the importance of pre-engineered building is very high, and it is the proper solution to a lot of problems we are facing in the construction industry. The project delays due to a lot of problems. It will create the delay in the projects. So the PEB help us to reduce the project time duration. A lot of time can be saved. It can be done in the factory, and it will be transported to the sites, and there all the components of the PEB will be assembled together. In the next slide, you can see a PEB building, and the PEB erection is going on. This was a project done by our company in Dubai. So how can we define the pre-engineered building? Components of the steel buildings fabricated in the factory and transported to site, and at site it is connected together mainly using nuts and bolts, and it will take a few days to erect all the PEB parts. But the major activity of this building system, it is happening in the factories. When a site is starting, they will make the foundation, they will do the other activities. So in that time, in our factory, we can fabricate the building parts and all of them will be shipped to the site, and at site we will be assembling one by one, and the building will be taking the shape in few days. So actually, a 10,000 or even 20,000 square feet building can be erected in 20 days to 30 days in a site. But if you go for concrete building, it will take 6 months to 1 year to create such a building in concrete. So the reduction of the time is the most valuable thing in the present world, and everybody wants to finish it off in a quicker manner without any problems, without having any quality compromise. So the steel building system is a proper solution for all these type of constructions. And the next slide, if you go to the next slide, it's a pre-engineered building, and sandwich panels are cladded. You can see the roof panels. Pre-engineered buildings are factory-made building components of steel that are transported to site and assembled together using nuts and bolts and erected at sites. Next slide shows a PEB building under construction for a UPS manufacturing unit. Actually, there was an existing building. You can see a part of the building visible at the left side, and they want to create a same building, similar like a twin brother or twin sister. Second building is required. The previous one was made in concrete, but they want the same ditto of the building. So we made this one, and finally it was looking similar. And in addition to this, we have made provision for an additional floor for them. So that means we made all the connections to create a new floor. But now it is having 2 floors only. When you want to create the third floor, the roof part, obviously we have to dismantle that one. Those parts will be kept on the ground, and the third floor steel structure, it will be joined to this second floor beams, and it will be raised by 1 floor. Then again, the roof which is on the ground will go to the top of the third floor, and it will be assembled, and all the wall claddings will be done. So it will become a 3-story building. That is the main advantage of the PEB buildings. PEB building, extension of a building and some modifications, it's very easy. And ultimately, when you want to make this same factory to be shifted to somewhere else, if you want to close a factory at certain place in a town or in a city, and you, because of certain reasons, you want to shift them to another state or another town, if it is a steel building, PEB building, it can be easily dismantled. Only thing is you have to remove the screws, nuts and bolts, and it can be transported to another site or another place, and again it can be assembled again. So the same building is recreated at some other place. And in the PEB buildings, you can make the structure of the steel structure according to the load criteria. Where there is wider or deeper, large forces are there, we will make deeper sections. And if the force is very less, then we can go for narrow sections. So what's happening in the previous days, the I-beams, ready-made standard I-beams were used for columns and rafters. So that will be extra cost. Where you need steel, you have to put that one, but you want to make that one optimum. So at certain places, deeper or wider steel is not required. So in that place, you can make custom made I-beams. That means the tapering columns, the bottom of the column will be narrow, and if it is going to the upper level, the width of the column will be more. And for the rafters also, rafter is the upper part which will carry the roof part. So in the rafter also we can have the wider beams as well as narrow beams designed and decided what size of the beam size, then it can be assembled at the site. If you closely examine the human body, the legs and the hands are connected to our body. The thickness of our flesh or the hand, it is more close to the body. Similarly, the leg, when it is joined to the body, that portion is wider, and coming down, the leg is getting narrow. Similarly, because where the movements are there, where the load transfer is there, so that area we have to take care, and those areas should be to resist the bending moment or whatever may be load coming, we have to use wider or deeper sections. If the load is comparatively low, you can go for narrow sections. So in that way, we can save a lot. And main advantage of the PEB is reduced project duration. Great, great speed is achieved because while the foundations and floor slab are being constructed, the beams and columns, the structural system are being fabricated in the factory. Once the foundations are and floor are done, the columns are shipped to the site, lifted into the place by cranes and bolted together. So that is the main advantage, because if you take the I-beam, it will be very costly. So we will be taking only plates. All the plates will be cut to size according to the requirement, and all of them need to be welded together at the factory to create I-beam or H section. Then if you complete the I sections, end plates should be connected, holes should be drilled, and all the rafters should be according to the shape of design. Says this is the depth at this particular place, at another place it will be narrower. So accordingly we will make the rafter, and all of them will be wherever the connections are coming, connection plates will be there. And now the components of the PEB system. Primary steel and secondary steel is there. Primary steel means the rigid frame, gable wall frame consists of column, rafter, and wind bracing. This system is, these parts are known as primary steel. That will be comparatively heavy. Then comes to the secondary steel. Secondary steel members are for roof and wall panel supports, roof purlin, eave and wall guts. Eave guts will be there, wall guts will be there, sag rods will be there. The purlins on walls is known as guts. The roof purlin will take the roof panel, and the side wall, eave, and this wall guts, it will receive the wall panel. Accessories in the sense, ridge ventilators, turbo ventilators, skylight panel, louvers, doors, windows, all these are the accessories, because to enter inside the factory or a warehouse, you need large doors, preferably with sliding doors, and to have some ventilation, you need some louvers, and some windows also required. From the roof, you can exhaust the hot air using ridge ventilator. It will be at the peak of the roof. Airflow will be there, natural airflow will be there. So the hot air, normally the density of the hot air is less, it will rise to the top of the building, and through the ridge ventilator, the air will be hot, air will be escaped, so you will not feel that much hot inside the building. So PEB system, primary steel, then secondary steel, and the accessories. So these the next slab, stay here. In this sketch, it's a schematic sketch. The rafter is shown, the upper part of the steel structure, that is rafter, and the vertical one is column. And on top of the rafter, there is some lines are shown, that is purlins. Then the roof sheet is shown, and the wall cladding is shown. Those walk doors are coming. Then gutter means the drainage system from the roof. A lot of water will be coming. It will be collected in a tray-like gutter, and all this gutter will be filled with water. Then it will be drained using downspout and downpipe. And again, skylight panel. At least in a warehouse, 5% of the roof panel should be skylight panel, polycarbonate sheets, which will allow the skylight to come inside the warehouse. So otherwise you have to put a lot of lamps or tube lights inside the warehouse to get the light. So in the roof, give some skylight panels, a lot of sunlight will come inside the building, and you can have a saving in the electricity. And turbo ventilators are kept on the lean side of the roof. It will be automatically driven turbo ventilator. When the wind is there, it will start rotating. So a small reduction in pressure will be there, so that air from the inside of the building, it will pass through the turbo ventilator. Then fascia, vertical fascia means some of the people, they don't want to see the top of this warehouse shed, so they will make beautiful fascia panels to hide the roof, and it will look like a square building. So these are the accessories. PEB comments, the accessory part is this one. Let us go to the next slide. This is a building under construction. You can see the rafters, columns, purlins erected, and bottom part of the building, it is having some block works also, but the columns are coming up to the ground level. It will be connected to the anchor bolts, which will be embedded in the concrete columns, which will be known as footing. Very deep footing will be made at around 2 meter deep. There will be a PCC, then they will cast a slab. On top of that one, they will make a huge column. Then again, a reduced column. At the ground level, a small pedestal column will be coming out of the ground level. At the top of the pedestal column, we will be inserting anchor bolts, and anchor bolts will be fixed with the rebar. The shuttering box will be done, and the anchor bolts will be kept in position using some templates made of plywood or steel with the same holes at the bottom of the column base plate, and the same holes will be made in plywood, and accordingly we will fix the anchor bolts in the concrete shuttering, and the concrete will be poured and it will be set. After setting the thing, we will remove the template, so that wherever the bolt is required, it will be available, and the thread of the bolts will be protected using some plastic covering. Otherwise, concrete will enter in that thread, and when you bring the nut, it will not tighten, or it will be very difficult to tight the nut. So the threaded portion of the anchor bolt will be protected during the concrete pouring. When we bring this column to the site, all of these members will be having considerable weight, and manually it cannot be erected. So we have to use a crane to lift these heavy columns, rafters. So it will be erected in such a way, all of them will be having some numbers, and most of the columns and rafters, it will be having the same size, and it will be numbered, the which is belonging to which grid, it will be numbered. So we will see that number, and according to the number, we will erect them. So the columns will be erected first, then the connecting rafter members. If it is a small rafter, maybe 2-3 parts can be assembled at ground and can be lifted in a single lift. But if it is a heavy rafter, so partially it will be the first column will be erected, then the next rafter member will be connected, and using some scaffold or something, maybe we will give some prop support at the joining place. Then we will bring the second piece, we will connect it. Again, some support will be given. Then from the both sides, the rafters will be erected, and finally the the middle rafter will be erected. The next picture also you can see some of the purlins resting on the rafters. The set purlins are used for the roofs. The shape of the purlin cross section is like a letter Z, and we will having some cleats to receive these purlins. So it will be having some holes, and the purlin also having the similar holes. So we bring the purlin towards the cleat, and bolt will be inserted through the holes, and the nut and washer will be tightened from the other side. So once we make the first frame, the first rigid frame, 2 columns and the rafter in between, that one we can call it as a rigid frame. So that will be erected first. Then we will go to the second rafter, second column. So it will be in the next grid line. So we will raise the columns first, then the rafter in between will be also lifted to the required level, and it will brought to the column top, and it will be connected using a number of bolts. So 2 vertical rigid frames are ready. Then they have to be connected using purlins. So we will use the purlin. It will be connected to the both the rafters. So both the rafters will be connected through the purlin. So it is stable now. Then we will start with the bracing bay. If it is the next slide shows the purlin connection. You can have 2 type of connection, but joint sleeved connection and overlap connection. But joint sleeve connection, the purlins will be brought together. Both of them will touch each other. Then in between, a short purlin piece will be acting like a sleeve. It will connect. It will catch both the purlin, and the sleeve will be connected to the cleat, as well as the purlins coming from left side and purlin coming from the right side will be connected to this. Then in the overlap system, there won't be sleeve, but instead of sleeve, the purlins will be overlapping each other. So the purlin, what is the center to center distance, we have to make the purlin longer than that, then only we can have some overlap. So purlins can be fixed using overlap system also. This is the purlin connection detail. It is the member coming on top of the rafter, and the roof panel will be connected to the purlins. It will be placed on the top of the purlin. Then screws will be used to fix the sandwich panel or single skin panel to the top of the purlin. Now let us go to the next slide. Here you can see from the machine, man lifting machine, you can see on the right corner, people are standing inside that bucket, so it will be lifted to the required level. So they will go there, and all the connections can be done safely. So this is also a project we have done in Dubai. The next slide shows the column rafter connection and the sheets in position. The skylights also erected. So this is the normal appearance of a PEB building after completion. You can see a series of skylight panels which will be giving enough light inside the building. And in this case, the one column is coming in the center also. If there is no central column, the rigid frame will known as clear span, and the multi-span building, it will be having a central column, or if it is too wider, maybe you will be having 5 columns or 7 columns according to the width of the building. Otherwise, only 2 columns and thereafter it will be stable, and if it is too wide, then you need to have a central column to support the center part of the rafter. In this picture, you can see all these parts. On the wall also they have given some skylight panels, so from the side of the building also we will get sunlight. Then structural systems. The structural system of pre-engineered steel building give it its speed and flexibility. This system consists of factory fabricated, factory painted steel columns and beam segments that are simply bolted together at site. The columns and beams are custom fabricated I-section members that have an end plate with holes for bolting at both ends. These are made by cutting steel plates of the desired thickness and welding them together to make I-sections. Still, it is economical. If you take a column, the base of the column may be 200 and upper part will be 700. So 200 to 700, there is a gradual reduction. So if you didn't make a custom column, you have to go for 700 wide column. So at the bottom, you need only 200, but you are using 700. So 50 centimeter is extra. So this will cost money. So if you go for ready-made column, today you can bring this I-beams and tomorrow you can start erection. Only end plate you have to weld. But if you go for the factory-made I-beams, you have to cut each part. The plates are cut to size, then they have to join together. So a lot of welding is involved. Still, if you calculate the cost of the welding and the labor involved in that one, still it is giving us more profit if you go for this PEB system. Standard I-beam was used in the previous days, but it is a loss. Then we started using this custom made according to the requirement, as per the design, what is the width and depth required for a column. For similarly to the rafter also, what is the required width, we will go for that one. Let us go to the next sample. This is a PEB villa done at our hometown. That sandwich panel wall and sandwich panel, it's a very congested place. So that place they want to make a jewelry shop and then 3 floors. So we made using steel building and we cladded with the sandwich panels and windows are inserted. The roof is having, it's a lean roof. A small inclination is given. Backside there is a gutter, and the 2 floors are little bit cantilevered. In the ground floor there will be a canopy like appearance. So the ground floor starts from little, so a veranda or entry space will be there. And this building we made using steel and it was cladded using sandwich panels. This one is light steel PEB member. Instead of steel beam, you can have some GI members rolled to certain shape. So the weight of the building will be very less. It's a but huge building we cannot make. Some factory sheds, some what do you call workshop sheds can be made using. It's all GI plates. GI plates bent to size, and we made light steel structure to make the panel fabrication. This shed was made for Qatar Khalifa Stadium project. We have to make a lot of panel modifications, a lot of some works are to be done. So this is made at site, and after the project we dismantled and brought back to Sharjah. So PEB building, When you want to have it, you can use it, and after that, it can be dismantled. Foundations and anchor bolts. The foundations for pre-engineered metal buildings are made with conventional concrete footing systems. The foundations are designed to firmly anchor the structures to the ground, preventing them from being blown away by the wind. Before casting column footing, the anchor bolts will be inserted between the steel bars kept in position in the shuttering box using the templates made of plywood or steel, having the exact holes made in the base plate of the columns. This one already I have explained to you before. Let us go to the next slide. This one is a close-up of a column bottom. You can see at the end of the column, there is a base plate and there was two holes for this one. And the other side, it is not visible. The similar two bolts are there. It's a small building and not having that. So 4 bolts are enough. If it is the big column, the number of bolts will be more. In this case, only 4 bolts are there, 2 on our side, 2 on the opposite side. You can see the washer is there, the nut is there, and normally, if it is a aesthetic point of view, you can clamp this column with some ACP or some cement board or something, so this will not be visible. If you want to close, the cladding can be used to cover the columns as well as bolts and everything. Then erection. Each piece of the system is very much alike section with end plates or bolting. The painted steel sections are lifted into place by crane, then bolted together by construction workers who have climbed to the appropriate position. So normally some scaffoldings will be required. Otherwise, in the previous picture, we have seen some man lifting machine. So people will stand in the bucket and the machine will allow them to reach the required level and required place. Usually, each connection calls for 6 to 20 volts to be installed. Bolts are to be tightened to exactly the right amount of torque is using a torque wrench. There should not be loose and the tightening should not be more. So a device called torque wrench is using for tightening the bolt. Then erection sequence. To erect a PEB building, what are the sequence? What are the activities to be done one by one? Anchor bolts are checked and cleaned. So the casting done by civil people, civil contractor. So we have to check the anchor bolts, and if the is there, you will place the template again on top of the. If you want to adjust the bolts, you can do that. Then it should be clean. Already some plastic cover will be there, but remove that one and clean the anchor bolts. Then the first column is lifted using a crane. Then the base plate with the holes, it will be brought to the anchor bolts, slowly lowering down. The anchor bolts will penetrate through the holes in the base plate, and the column will rest on the concrete footing. That time, washer will be inserted through the anchor bolt. The nuts will be tightened using spanners. All the nuts should be tightened because the column should stay rigid and in a vertical position. Erection sequence next one is similarly the second column opposite to the previous one is installed, because if you want to make the rigid frame fully on left side column you will do first, then go to the right side column. It should be lifted the similar way. It should be brought to the anchor bolt. It should be connected. It will be tightened using the nuts and bolts. It will be kept in the required level. The rafter pieces are lifted using crane and all are assembled together one by one. Sometimes the rafter will be having 3 pieces. So the first column will be erected, then the first rafter piece on the left side will be erected, then the last piece of the rafter, it will be connected to the right side column. Then there will be a gap in the middle. So that is the middle piece of the rafter. So the crane, again, it will lift the middle piece, bring into the gap of the two rafters, and plate to end plate are brought together, and all the bolts, whether it is 12 or 20 or 30, all the bolts will be inserted, tightened together. So the rafter will be joined together, and the rafters are both the columns are connected to the rafter. So it will be become another second rigid frame will be ready. Then the roof purlins are fixed to the cleats on the rafter. Both the rafters will be having cleats, a lot of cleats. How many purlins are there? So 1 meter, 1.2 meter is the spacing normally given to the purlins. So at these locations there will be cleats. So purlins will be placed near to the cleats. Bolts will be inserted. It will be tightened. Here you can see the bracing also can be done because both the column will be having X-like column bracing. So then it is very safe. The next picture shows erection of the columns are staying there. Then some wall gates also can be connected to have a connection between the columns. Then from the other end, the second rafter is third one also done. Then both of them will be connected using the purlins. Then the same sequence will be repeated again and again. So the erection of the EAB will be done like that. Here you can see a close look of a rafter lifted by this crane, and it is in position, and all the bolts will be connected. Then rafter column connection, it is completed like this. This is also same side. You can see the next rafter is in position. It is lifted and erected. So this has to be repeated one by one. It will be coming to the other end. So in the steel building, you see the panels are erected here. You can see the roof panel resting on the purlins. The rafter is there. Columns are there. Outside the column, there is some panels. And at the bottom level, some block work, and it is plastered and painted. At the other end of the wall, that is known as gable wall, there also the panels are erected, and you can see two doors are provided in the gable wall, and there is a center support at the gable wall. There is a column at the middle. So in the gables, normally we will be having more columns, but the other rigid frames will be having only two columns. Rafters will be connected to these columns, and purlins will be connected, and these purlins will be taking care of the roof panels. And you can see some bracing also on the roof. This is the picture of a self-drilling screws. At the tip, you can see some drill bit like you can see. That one will make a hole, and the tapping, self-tapping activity happens. It will cut threads on the purlin thickness, and it will be going inside the sandwich panel. So according to the thickness of the panel, the length of the bolt will be, the screw will be bigger. If it is a small panel, you will use smaller screws. Otherwise, you will have to use, according to the thickness, the length of the screw will be higher. The next one also, you can see the washers also. This is Pdm washer. This is comparatively thin screws. This is also used for the erection of the panels. Normally sandwich panel. If it is a sandwich panel, longer one. Otherwise, if it is a single skin, only 25 mm long screws is enough. But it will be also having these washers. So for tightening, there is a machine, tighter machine. So the other one is some again some roof panels resting on the purlins. Rafter system is there. On top of the rafter, you can see the set purlins. On panels are resting on the roof purlins. On the sides, you can see wall panels also. Erections. In the gable and frames, more columns will be there. All of them are to be erected one by one. Here you can see a gable frame. This is a small shed, so in the gable only 2 columns are there. Then erection process. Wall panels are erected on side walls as well as gable walls. Skylights, ridge ventilators as well as turbo ventilators are also can be installed. Then all the flashings are to be fixed. Flashing means the junctions are to be covered with flashing. If the roof panel and wall panel meets, so that side there will be a flashing, L-shaped flashing. So it will take care of the leakage. So water will not penetrate inside through that gaps or joints. Then rainwater gutters will be fixed prior to roof panel. Before fixing the roof panel, at the bottom side of the roof, we will install the rainwater gutter. Then they will be joined together. Gutter joints will be there, so gutter will be joined. Then after that, we will connect the downspout. Downspout is like a funnel-like pipe piece, which will take the water from the gutter to downpipe. Downpipe is the PVC pipe used for bringing the water to the ground level. Practically, they are fixed. There will be some clamps to fix the downpipe. The next one also, the buildings with some purlins in position, columns on erected. The bracings also you can see. The other one also, the building is under construction. Columns are erected. Purlin started the purlin erection. Then the mezzanine floor is coming. So in the middle level, you can see huge beams horizontally placed. So it will take care of the decking panels which will come on top of this panel. Lightweight concrete will be poured in the decking sheet. If you want to have some rebars, that also can be used. So it will be act like a floor, and on top of that one you can place the tiles, flooring tiles, and you can walk on it. So in the steel building, everything is possible. In the ultimately, when you look, it will look like the normal building. The next one is church. In the church, we have concrete columns and the steel rafter. So the concrete rafters, the steel rafters are resting on concrete column, and top of that one, sandwich panels are erected. So it will be having a very cool atmosphere. A lot of ventilation is there. So you can see the lights coming inside. So this is for a church. We have made this project for a church. Let us go to the next slide. This also shows the erected steel structure and almost the purlins on the both the pictures. You can see the purlins are erected. Then side guts are not done, so we have to do some side guts. Then on side guts, we will fix the side wall panels. These are all different sides. Just to have some idea, I'm showing you these pictures. Then main advantage, less weight and lower cost. That is the advantage of the PEB buildings. Less time period for installation. Then removable and reusable. Easily it can be removed and it can be used again. Some building they will go for some new brand or new material, but the old one they will scrap it. So some other people they don't have money to purchase new one. So what they will do, they will go for some second-hand building material. All of them will be removed from the first place. It will brought to the required place and it can be reinstalled again, or we can have some modification, but all these are reusable. And ultimately, after a long time, if you want to recycle it, all the steel material, it can be recycled and new products can be used using this recycled material. Future expansion is easy. If you make a building of 50 meter long, after some time, if you want to have some extension, if you want to increase the length of the building from 60 to 100, easily it can be done. Only thing is you have to remove some gable wall, then extend the connections. Again, this gable wall can be shifted to the required grid, and in between the roof and the wall panel you have to fill it. Then the extension of the building can be done very easily. Same way, the modification, that also, if you can predict this is the modification I am going to do, so the features can be done early. Otherwise, even after erection also, some drilling holes, some plates added to the existing building columns, it can be, the modification can be done very easily. The recycling is also possible. Attractive prices means the total price is very comparatively very less, so it is very attractive, faster construction. Then one more thing, a single contractor or single manufacturer will be doing the project. So only thing is, only one man or one company will be doing the all activities. So only we have to contact them, so they will do. And the duration also, the steel is still last for, if it is properly painted, there won't be any rusting, it will stay for a long time. Then saving in the steel, it is, since it is custom design, so lot of saving will be there. In steel building, you can have some mezzanine floors in between the ground and the roof. You can have some mezzanine. On top of that one, you can have some storage facility or some office facility, or in certain portion of the warehouse, you can have some raised mezzanine floor. Some of the offices can be accommodated that area, or some storages for the. Then the most important thing is there is no debris. If some flat or some huge buildings are scrapped or demolished, heaps of debris like mountains will be accumulated, and to remove this debris, it's a very huge task. So in steel building, such rubbish or debris will not be there. So it is very for the environment point of view, it is like we will get clean atmosphere or clean environment. It will not spoil the environment. All the material can be taken back or recycled, or some other people will be using that one, or we can shift the same building to some other places or to some other plants. We are having some requirement, we can shift it to that one. Then applications where this warehouses, factory building, schools, aircraft hangars, auditoriums, workshops, PAB villas, shopping malls. Warehouses, to store the building, we can have huge warehouses without any hindrance. The forklift or some other machines, it can travel inside the warehouse. On the columns, we can provide the crane brackets, and cranes can be accommodated inside the warehouse. So these cranes will travel inside the warehouse. Wherever you require to lift the material, the crane can come. It can be controlled using the remote control. Then factory building. According to the factory requirement, a lot of factories they use the PEB buildings. Then for schools also, schools. Hello.
Yes, sir.
Hello, can you hear now?
Yes, sir.
For the schools also nowadays, we are using the PEB buildings. Easily up to 5 floor, we can go in this PEB, using the PEB. Easily you can, I have shown you the 3-story building before. So the same way, up to 5 floor, easily we can make the PEB buildings up to 5 floors. Then comes aircraft hangars. Aircraft hangars are huge sheds where the entire plane has to enter inside that hangar for the repairing purpose and to do some modification. Then, or even for scrapping. So for all these aircraft hangars is a very huge building with a special type of doors and high-rise roof skylights, sliding doors. So these aircraft hangars easily we can made using hangars. Auditoriums also. In the auditorium, the front side of the auditorium, you can have some ACP cladding, some glazing, and the internal parts, you can have some ceiling, and the walls we can use cement board panels. Then it will look like the normal concrete building, and at the same time, the construction time can be reduced. The appearance will be very pleasant. Then the cost also, the cost is the investment. That is also very less compared to concrete. The time required to complete this, to start the project and to complete the project, it will be very less. So nowadays, auditoriums, a large number of auditoriums, all of them they are using. They have given up the concrete construction. They have started using PEB to make the auditoriums. And workshops. Workshops also you can have some ventilations, skylights. All these required things can be done. Now, instead of the ridge ventilator, all this one adopting natural airflow. Nowadays, power-driven turbo ventilators are also available. For example, the painting shops, welding shops, some foundries where the metal is molten metal is there. Then here a lot of heat will be generated and it will be very horrible condition. So the workers will be suffering like anything, and they will come out to have some breathe after getting sweat and all. They are becoming tired. So in these places we have to use power driven ventilators. So some companies they have started making this type of ridge ventilators power driven. Approximate cost of this ridge ventilator power driven ventilator is around 16,000. The turbo ventilator, I think we will get at the range of 10 to 12,000. 16 to 18,000, you will get a power driven ridge ventilator. If you place 4 or 5 ventilators in a hot area, all the air, hot air will be sucked from inside the workshop and it will be thrown away. Recently, we have fixed 4 ventilators in a melting unit. They are making some glass bottles as well as some covers. So some furnace is there. So all the people are getting very tired. They put a dozen or more than that, the turbo ventilators, but of no use. So when there is a wind, the turbo ventilator will work. But if it is a still air, it will not be sucking the air. So the people were having some trouble. So the owner, he showed this ventilator in an exhibition. Then he purchased 4 of them. Then I have sent some people to erect these ridge ventilators. The supplier was from Bangalore, so he came to me. Then we installed those 4 power-driven ventilators on that workshop. Then now they are pleasantly, they are working. They don't have any problem. The air inside the workshop is very cool. If the hot air is thrown away, naturally the cool air will enter inside the buildings. Then comes to PEB villas. In Kerala, one of the forest department building, we have done a villa-like building. Unfortunately, I didn't have a photo of that one. So the structure of the building is done in PEB, and all the columns are covered using some cladding material, and the sandwich panel roof and the sandwich panel walls, it will keep the building cool. And we have UPVC windows and UPVC doors, all the vision panels, everything done. So it's a very, very beautiful villa. Only thing is, we have to be little bit careful, and the PEB villa, it can replace the normal construction concrete buildings in future. So the PEB villas will be in use. Then comes the shopping malls. Shopping malls also a very large area has to be covered in different stories. So easily we can make a floor using decking panels. So only thing is you have to make some horizontal beams and joist beams. The decking panel, it will span only 5 feet. So that means at each 1,500 there will be a joist beam. So 1.5 span, you make a series of joist beams, and top of that one you can put a decking sheet. On top of the decking sheet you can make the normal RCC or lightweight porous concrete is coming. So lightweight concrete can be poured, leveled, and on top of that one you can place the walking tiles. So it will look like the same building. And if the walls are created using cement board, so fiber cement board panels, after erection, the joints will be sealed with some tapes. Then they will put some putty. Then they will paint it. So the wall will look like a concrete wall, but beautifully rendered, beautiful looking, aesthetically very nice. Then all the windows and the doors, we will have some door jams, window jams, sill flash, sill channel. So the frame will be done, and whatever type of the window, it can be mounted on this channel frame. Similarly, for the doors, we will make a door frame, and on top of the rail, you can do the for a sliding door. The top channel will be having some features for this. It can be erected and sliding panel can be accommodated. Or if it is a rolling shutter, that also can be done. Nowadays, folding door panels also, machine operated door panels are also in use. So it will having a track to guide the this door leaves. So it's like bending sheets, so connected together. So it will slide inside the building. The rail will take care of that one. Once it is it is controlled by machine. If you switch on the machine, automatically the door will go up. Then when you press, it will come down. Even sensible type doors also nowadays people are using. When somebody comes, automatically the door will go up. Otherwise, so these are the main features of PEB buildings. So let us conclude once again. So pre-engineered building can be defined as the building components or the steel members are fabricated, painted, and plates, everything is fabricated at the factory, and the finished materials, finished members are transported to the factory, and it is unloaded there safely. Then erection is done using the cranes, the columns, the a column rafter combination. It is known as a rigid frame. At the gable, at the both end of the building, it is known as gable. On sides of the wall, it is known as the side walls. So all the columns will be on the side walls. In the gable wall, there will be intermediate columns. All the rafters columns are connected. Then purlins will be fixed on top of the top of the rafters. On the columns, side guts will be fixed to receive the wall cladding. On the gable also, you will have to use some gable guts. Then roof panels will be erected on top of the purlins. They will be screwed using the self-drilling screw, which I have shown you. Then the gutter will be in position before we put the roof panel. Gutters will be having downspout, which will receive the water from the gutter. It will transfer the water to downpipes. Downpipes are vertical pipes connected to collect the water from the rainwater gutter. Then it will be having some elbow at the bottom. It will throw away the water, or you can have some huge pipe in which all these gutters will be connected, or it can be connected to drainage in the ground floor. Then comes the flashings. After the roof panels and wall panels are in position, all the junctions are to be sealed with flashings. So it will give you a watertight roof wall junctions, and the screws which we are using for fixing the panel will be having some Pdm washer. So it will stop the water entering inside the building. There also the tightening of the screw should be done in a way. It will be should not be loose, should not over tightening, should not be there. Then comes the accessories. Accessories is ridge ventilator, turbo ventilators on the roof, then skylight panels, then windows, doors. All these comes under the accessory items. So when all these things are done, then the PEB building, we can say, it is successfully erected. Have a look when you go outside. At least have a look on the buildings on both sides of the road, or try to visit some sites where the erection is going on. Then see some workshops or some warehouses where you can look up and you can see the purlins on the top, the rafters running through the column to column. Rafters are running, and you can see the vertical columns and the purlins connected to those vertical columns, and the sheets connected to the wall guts, and the door frames, the channels given for the windows, and the channels given for the doors. All these things. Try to visit some sites or some finished project also. You can have a visit, and visually, if you see, open your eyes and see all these things, then what I have told you will come into your picture, and you will not forget it again. So if you get some time, try to visit some of the finished project or some of the projects which are going on. It will be very, very helpful to you to learn a lot, because in future you will be the manager or you will be the project engineer to handle such projects. So you should be having some exposure to. If you didn't taste a food or if you didn't smell a fruit, you will not, if you write it in words, you will not get the right feel. You can write on board sweet, or you can write tasty, but you have to taste it, then only the real taste will be uh, experienced by you. So at any cost, try to visit some of the projects, and it will give you a clear picture of the vague things which I have told you. It's not a very, very wide one, because I want to cover the maximum points in the limited time. And I have some projects pictures I have included in this presentation. So all these things together had given you little bit knowledge about pre-engineer building. That is what I believe. And thank you so much for cooperating with me and for giving me an opportunity to give a talk on technical subjects. So hope that today there was a trouble in the mic problem. Otherwise, we should have got some more time. Thank you so much. Thank you so much. So once again, thanking all of you. Let me stop.
Thank you, sir. Students, have you any question? Aditya, Mukesh, if you have any question, please ask.
No, ma'am. No.
Okay, sir. I think there is no question. So thank you so much, sir, for your session.
Okay, okay. It's a pleasure for me to join a group like yours, and to share the knowledge. It's like sharing the wealth. If you have the knowledge, you will get a job. Then the wealth automatically it will come to you. So it's a nice experience to have a session with you, all of you. Thank you so much. God bless you all. So after some time, when I go through some of the cities, I should see all of you working somewhere as project engineers, project managers. So try to learn a lot. Try to get the knowledge. We should be greedy of knowledge, not greedy of money. We should be greedy of knowledge. So accumulate the knowledge. It will bring you nice opportunities, and you catch those opportunities, you will come up in your life. God bless you all. Thank you. Thank you so much.
Thank you so much, sir. Thank you.
Thank you, sir.
Welcome. Welcome. Welcome.